All right, guys, so continuing with our polynomial functions, there's one last thing that I want to look at before we're going to start graphing these things, that's something called end behavior. And what end behavior is let's take a look at the graph of f of x equals x squared. That's a parabola that looks like this, for the most part. And what end behavior is let's say we start from the middle of the graph and we kind of work our way out. What I want to know is what direction is the graph going as we go, to the left and to the right. So right now it's going this way. So if we go left right now, the graph is kind of curving up in the up direction. And then as we go to the right, it's going in the up direction also, okay? So the end behavior of this graph would be up and up. That's what the graph is doing. It's going up and up, all right? Let's look at f of x equals negative x squared. If we remember our translations and transformations and stuff, this is the same shape, but it's just facing down. So this one would have end behavior that is down and down. All right, so down and down is the end behavior for this one. Okay. Let's look at another one here. Let's do f of x equals x cubed. Remember what this one looks like. Here's the xy axis. The x cubed function looks something like this. And then we'll also look at f of x equals negative x cubed. And it looks something, it would be this one just flipped over vertically. So it would look like this. Okay. So this one has end behavior that is down and up. So this would be down and up. And this one has end behavior that is up and down. Okay, so why is this important? Why do we care about this? Because if you notice, this one, the exponent it's a squared one, okay? And so again, we're gonna be looking at, is it even or is it odd? Last time we were looking at is a multiplicity even and odd. Here we're gonna look at, is the exponent even and odd? These ones up here have an even exponent. And something interesting about all the polynomial functions is if the degree of the polynomial function is even, so x squared, x to the fourth, x to the sixth, all the even polynomial functions will have the same end behavior. So the graph of like an x to the fourth times whatever it is, doesn't really matter. We just look at the first term. So like, for example, if we had something like, I'm going to add a little one right here. So if we had something like, 4x to the sixth minus 2x to the fifth plus 9x to the third plus 4. If this was our function right here, all right, we look at this first term, it's an x to the sixth. X to the sixth is an even degree, so its end behavior is going to be up and up. There might be some extra little things in the middle. It might do some weird little kind of, it would come down and do little loopy things, but at the ends of the graph, it would end up be going up and up. There'd be some middle stuff happening, but up and up is still be the end behavior for this one, all right? Because the first term here, that's called the leading term, is to the sixth, is an even exponent, so it would have this end behavior. If it was a negative out front, it would have this end behavior, down and down. All right, all of the even exponent, all the even degrees are going to have the same end behavior. And so on the flip side, all the odd degrees are going to have this end behavior. They're going to have down and up or up and down if it's negative. Okay, and so in this case, if we had something like f of x equals like 7x to the fifth plus 9, why not? Let's just do that. This would have this same end behavior. It'd be down and up because it's positive and it's odd, so it goes bam bam, and that would be our ultimate end behavior. Right? The graph would do other stuff in the middle and stuff, but all in all, it would have this end behavior. Okay, so now that we have end behavior, we can put all the things together and we actually start graphing these things. Let's start graphing these things on the next one here.